Sec 1 Chapter 10.2 Part 1 Sequences. Now in this part of the chapter we're going to learn about what is a general term, and we're going to try to find the formula for the general term of a sequence, and then we're going to do the higher level questions where we solve problems involving sequence. What is a general term? Now in this case, usually we denote it by Tn. Tn is called the general term, okay, where it means for the formula, if you're given a formula, t to the power of n is given to be some formula. Okay, so this means when if it's t1, then n will be equals to 1. If it's t20, then n will be equals to 20. And I'm going to use n equals to 1 or n equals to 20 and sub it inside the formula to find any term in that particular sequence. Now, if we know the formula to find the general term, we can use it to find any term in the sequence. For example, if the formula for Tn is going to be, let's say, 2n minus 1, okay, then we can find any term in the sequence by substituting the corresponding value of n. What does this mean? For example, if I have the formula Tn is 2n minus 1, that means if I want to find term 20, n will now be equals to the number 20. Then means term 20 will follow this formula, 2 times n minus 1, and I'll put n to be now term 20. So this term 20, will follow this rule, this formula, and give us the number to be 40 minus 1, which is 39. That's just one example. Let's try a little bit more questions. Now let's try to find the nth term of a sequence. Okay, given the formula, we're going to sub the corresponding value of n. Now, in this table over here, find the first term and 100th term of each of the following sequences. So, for example, part B, Tn equals to 3n minus 5. That means 3 times n minus 5. That means when I have term 1, now what is the value of n? N will be the number 1. Then I will sub into my formula and I get 3 times 1 minus 5 to give me the answer -2. If I want to find term 100, that will be T100, and n is now 100. Substituting it into this formula here, we have 3 times 100 minus 5. That gives me 300 minus 5, 295. Let's try a little bit more. Part C, Tn equals to n squared minus half of n. So when it's term 1, right, n will now be equals to 1. So I'll get 1 squared minus half or times 1. 1 squared is 1 minus half, and the answer will be half. How about T100? T100 will be substituting 100. So 100 squared minus half times 100. And that gives me the number 9950. Now we'd like to try the following questions over here and then come back with us to check the answers. Have you gotten the answers? Up next, I'll be introducing some of the possible types of sequences. Please write down the following examples into your exercise book. You can pause the video to do the copying of the questions, or you can pay attention first and then do the copying of the questions later. Now, let's consider the following type. Type number 1, where we add or subtract a common difference. Now, what does this mean? Consider the following sequence down here. Let's say we have the number from 3, 10, 17, 24, and 31. What do you think is the pattern? Now from 3, how do we get to the number 10? We can add a 7. And then from 10, we are still going to add 1 7 to get 17. And then another 7 to get 24. And 7 to get 31, so on and so forth. Now, when we want to find a general term in this case, for this sequence, we're always going to start with in relation to the first term. So we're going to find a formula that allows me to substitute some number inside, and I'll always be able to get the answer. So now let's take a look at the following. Now, when n is equals to 1, that means the first term itself, t1, over here, I get the number 3. And then when it's t2, I got the number 7. How did I get 7 from 3? I got 7 from 3 by taking, I got the number 10. How did I get the number 10? I got the number 10 by taking 3 plus 7. Now, how many times have I added the 7? I added the 7 1 time. Right? Now, then what's our next term? Term 3. What is this number? I got 17. How did I get this number 17? From the very first term, from number 3. I took 3. I added 7. 1, 2. I added 7 2 times. If that's the case, can you tell me what is n equals to 4? For the fourth term, term 4, the number is 24. Let's try this pattern. I started with 3 plus 7 times. What is this going to be? Now, this will be number 3. So I'm going to take 3 and I add 7 3 times. Now let's go back to this first sequence. If this pattern is going to hold, then let me check. I will start with 3 and I'll add 7. How many times have I added 7 then? If 3 plus 7, that will be 10, right? But I'm not going to get 10. I got the number 3. So in this case, it means I'm adding 7 0 times. Now observe the following. When it's n equals to 1, term 1, I added 0 times. How to get 0 from 1? When it's term 2, n is 2, I added 7 1 time. How do I get 1 from 2? When it's 3, n equals to 3, term 3, I added 7 2 times. When n equals to 4 and term 4, I added 7 3 times. Can you tell me if n is now equals to 50, my term 50 following this pattern will be what number? That means I will take 3, I'm going to add 7, but how many times of 7 am I going to add? Well, I got 0. I added 0 when it's one term. I added 1 when it's the second term. I added 2 when it's the third term. I added 3 when it's the fourth term. So now what should I add in order to get the 50th term? Well, the answer is 49. How did I get 49? I took 50 minus 1. If I were to have n equals to 100, what will be term 100? Following the pattern, I took 3, I added 7, but how many times of 7 did I add? This is term 100, but I added 99 times. How did I get 99? This came from 100 minus 1. How did I get 49? This came from 50 minus 1. Now, if I were to find the nth term, Tn, how am I going to find the pattern or the formula? I'll follow the pattern and I'll have 3 plus 7. How many times of 7? N minus 1 time. Following this pattern over here. But in algebra, this is not the simplified form. So I have a pair of brackets down here. What do you suggest I can do? Well, we have to expand and simplify the brackets. So we're going to multiply it inside. We'll take 3. 3 is on its own. But 7 is multiplied to n. So I have 7 groups of n and 7 groups of -1, which gives me -7. And in this case, the formula will be 7n minus 4. So therefore, the general term will now be Tn equals to 7n minus 4. Now for this type of sequence where we add or subtract a common difference, the term Tn is usually given by the general term formula will be A, that means this is the first term, plus D, this is given by the difference, times n minus 1. And simplifying that will usually give us the answer to the formula for this type of sequence. Let's try this on another sequence. Given this question over here, I have the following sequence: 201 to become 186. What is the difference? The numbers are all getting smaller and smaller. So actually I am subtracting a difference of 15. 186 subtract a difference of 15, a difference of 15, and a difference of 15 will give me the next few terms. So now let's consider the following. If I were to use this pattern, let's take a look. When n equals to 1, that means I will have term 1. The number was 201. When n equals to 2, that's term 2. I started with 201 and I subtract 15 n minus 1 times, which is from 2, you drop to 1. And that gives me the number 186. Now, if I have n equals to 3, term 3, I will start from 201. I'm going to subtract 15, but how many times? When n is 3, term 3, but I subtracted only 2 times. So to get to the third term, I skip skip, I only do 2 times. So give me the number 171. Now, can you make a guess what will be term 7? If n is equals to 7, following this pattern, I'll get 201 minus 15, but if this is term 7, I'll get 201 minus 15 6 times. And that gives me an answer of 111. Let's take a look. Term 1, 2, 3, 4, 5. What is term 6? And that gives me 126. What is term 7? Hey, I got the number 111. So therefore, this property holds. If I'm going to use my formula over here, what will be Tn, the general term? When it's n, term n will be, taking my very first term, 201, plus a difference, but now I'm not adding a difference, I'm subtracting a difference of, when it's n, I will subtract 15, n minus 1 times. Now this is not the simplified form. I have a pair of brackets over here, so I need to expand and simplify my answer. And I'll get 201 minus, subtract 15 groups of n, negative times negative, subtract negative 15 groups of negative 1, that gives me plus 15. And I'll get the answer to be 216 subtract 15n. In general, this is given by the formula Tn to be taking the first term, a, adding a difference. Now this difference is a negative number, and then the difference is multiplied to n minus 1. Now this is called the formula for the arithmetic progression, where we add a constant common difference. However, this is not the only method to find the answer or general term for this type of sequence. Now let's explore a different method. Let's consider method number 2. Now in the previous part, we have this same sequence over here. We know that we add a common difference of 7. So we keep on adding 7 to each term. By my first method, using the formula, it says Tn is made up of taking the first term, 3, adding a common difference, 7, multiplied to n minus 1. And we get the answer after expansion to be 3 plus 7n minus 7. And that will be 7n minus 4. This was given to be the answer in the first method. Now in my second method over here, we have a little bit of a shortcut. So now I know that we are adding a constant difference of 7, right? So in this case, we will start with 7n. And we need to find out what do we need to do to 7n in order to get to the answer. Now when n equals to 1, 7n will means it will be 7 times n times 1. Now, but our first term is the number 3. Term 1 is number 3. What do I need to do to 7 times 1, which is 7, in order to give me the number 3? Well, 7 minus 4 will give me the number 3, isn't it? So now what we're going to do is we're going to apply this pattern and see whether it fits for the rest of the term. When n equals to 2, if I were to follow this pattern, where I take 7 times the n, which is 2, minus 4, I will get 7 times 2 is 14. 14 minus 4 is 10. Eh? That gives me the number again. So now if I were to have n to be equals to 6, what will be the sixth term? T6 will now be 7 times 6 minus 4. 42 minus 4 will give me the number 38. Let's check. Term 1, 2, 3, 4, 5. How do I get term 6? I'm going to add 7 and it gives me the number 38. So therefore, this formula here, 7n minus 4 is true. And the term and general term will now be 7n minus 4. Let's consider the next example. If I were to use my first method, I will have Tn to be taking the first term, but now I'm subtracting a difference. I'm going to subtract 15. So taking the first term, 201. I'm not going to add a difference. I'm going to subtract a difference. And this is multiplied to n minus 1. So that formula will give me 201 minus 15n plus 15. And I get my answer to be negative 15n plus 216. Now let us see if it's method 2, how can we get the answer? Right? For method 2, I know that I'm adding in a common difference or I'm subtracting a difference of 15. So my formula will start with negative 15n. Now let's check. When n equals to 1, if I have the formula to be term 1, negative 15 times 1, what do I need to do to it in order to get the number 201? Well, I need to add 201 plus 15, 216. Let's check. If n is now equals to 2, if I were to follow this formula, term 2 will be negative 15 times 2. And I'm going to add 216. Let's calculate this. What do I get? Negative 15 times 2 plus 216. It gives me 186. And this is true. So therefore, if I do by this method, Tn will be negative 15n plus 216. So Tn is equals to negative 15n plus 216. And the answers are the same as each other. So now you have method 1 by formula. Formula says Tn is a plus d times n minus 1. Or you can use the second method where you start with 7n and then you find out what is the number I need to add to it in order to get the first term. Which method do you prefer? You may use any one of the methods to find the answer. Some possible types of sequences. Now type 2, perfect squares or perfect cube. Now you can take some time to copy down the questions by pausing the video, or you can write down the questions after you finish watching this part of the video. Now let's consider the following sequence. 1, 4, 9, 16, 25, and 36. What do you notice? If I were to do an addition, plus 3, plus 5, plus 7, plus 25 minus 16, 9, and plus 36 minus 25, 11. We notice that the number keeps increasing, and maybe you'll notice that, oh, it's 3, 5, 7, 9, 11. These are all the different odd numbers or whichever. It can be done in that way, but if I were to ask you what is the more 100 term, how am I going to find the answer? I will need to know the answer, the term before that. So if this is the case, we cannot use this kind of method to help us find the general term. We need to find a formula where, given the formula, I can find any one of the term and I don't need to rely on the term before that. So like for example, if I want to find, this is 1, 2, 3, 4, 5, 6, 7, 8. I want to find term 8. If I were to use this method by adding, I'll need to know what is term 7 in order to get to term 8. But when I do a formula for general term, I cannot rely on the term right in front of that number. So this case, this kind of pattern will not work. Now what do? We'll notice that the numbers are all increasingly in quite big. Okay, so we'll try to see, first thing we can consider is perfect squares, perfect cube, or even power form. So now this is actually 1 square, 2 square, 3 square, 4 square, 5 square, and 6 square. So if I were to give you the nth term, let's say term 100, what will it be? It will be 100 square. So if it's term n, that will be n square. Now this is the first most basic type of equation that you should realize. Okay, so I probably need to encourage you to memorize this series 1, 4, 9, 16, 25, and 36, so on and so forth. Now there can be a couple of spin-offs from perfect squares. So now let's consider the following sequence. 4 plus 7, 4 to get 7, 7 to get 12, 4 plus 3 gives you 7, 7 plus 5 gives you 12, and so on and so forth. You see the numbers again, they are not the same. It's not a common difference down here. So I'm not going to use this pattern, but I observed that the numbers are growing bigger. So let's try. If I were to try a couple of series of perfect squares, 1 square, how do I get 4 from 1 square? Not very sure. Never mind, let's take a look at 7. How about 7? How do I get 7 from 2 square? 2 square is 4. 4 plus what will give you 7? Then how do I get 12 from 3 square? 3 square is 9. 9 plus what will give you 12? Oh, let's observe. I have 1 square plus 3. That'll be 1 plus 3 will give you the number 4. 7 square is 7. I'll get 2 square plus 3, which is 4 plus 3, 7. What do you think will be this term? This is 1, 2, 3, 4, 5. The 6th term. If I go according to this pattern, it will be 6 square plus 3. So therefore, for this kind of pattern, term n will be, if it's a 6th term, I get 6 square plus 3. If it's n term, I'll get n square plus 3. There can be many different types of patterns with squares in it. So I can't give you a conclusive summary list, but here are some of the patterns you should take note of. Next, let's take a look at, for example, for perfect cube. In this case, the question actually gives us a particular pattern. When it's term 1, I'll get 1 cube plus 2. When it's term 2, I get 2 cube plus 2. When it's term 3, I have 3 cube plus 2. Term 4, 4 cube plus 2. What do you think will be the 88th term? That will be 88 cube plus 2. So in general, if I have Tn, the nth term, I'll take n cube plus 2. Have you gotten the answer?